Hi, this is Mr. Bayless. Today I'd like to talk to you guys about a problem that has come up in class recently, or a particular class of problems that has come up recently in class, and that would be work problems. Okay? In order to do our work problems, there's really one equation that you need to remember, that the amount of work completed is equal to the rate at which you're working times how long you are working, time. Okay, rate times time equals work. For example, if I'm a copy machine and I can print out 10 pages per minute, you give me 10 minutes, we would take 10 pages per minute, multiply that by 10 minutes, and you would get that the amount of work I've done is to copy or print out 100 pages, okay? Which is normally given with respect to some amount of time or some unit of time. For speed and cars traveling, we would say miles per hour. Pages per minute for copy machines or printers, things like that, okay? Rate times time equals work completed. Now we can change the form of this equation. We can actually turn it around, and we can divide both sides by time and say that rate is equal to the amount of work completed divided by the time it takes to be done. Okay? Today we'll be looking at the theory behind this, and then I'm going to try and give you kind of a shortcut method. But in the first one, we're going to kind of go through this problem using a long method, and then try and figure out how we can make this problem a little bit simpler, okay? So let's take a look at one of the problems from class. This is: an old pump requires 9 hours longer to empty a pool than does a new pump. With both pumps working, the pool can be emptied in 6 hours. Find the time required for the new pump working alone to empty the pool. Okay, so a lot of times with problems like this, with distance equals rate times time or work equals rate times time, I create a chart. We have two pumps. We have an old pump and we have a new pump. Okay, the old pump is probably going to pump out water out of a tank or out of a pool in a slow fashion. So it has a different rate than the new pump does. And the time is given for us, right? Working together, we know that the pool can be emptied in 6 hours. Okay? Both pump working 6 hours, and the work that gets completed is just the product of their rate times their time. And that's going to be this box right is going to be the work that the old pump does. This box down here is going to be the work that the new pump does. And what we know about these two things is the old pump's work, right? The old pump's work plus the new pump's work, which I have here in green, that in that 6 hour, the amount of work that they complete together is going to be one pool emptied, right? That's the total amount of work that gets done by the old pump plus the new pump. They empty a pool. Now, to finish this, I just need to know what is the rate that the old pump works and that the new pump works. So I go back and I look, and it gives me some information. It gives me information that the old pump requires 9 hours longer to empty pool than does a new pump. Okay? The old pump requires 9 hours longer to empty a pool than a new pump. So I need to try and use this information to fill up rate. Well, what do I know? I know that my rate, the rate of either one of these pumps, is equal to the amount of work they do divided by the time it takes them. And if we go down to the last sentence of this, it asks me to find the time required for the new pump. Okay? And so what we're going to use is we're going to use this idea that, if it took the new pump, let's say 4 hours to empty a pool, then what is the rate at which the new pump works? If the new pump took 4 hours, how much does it do every single hour? What is the rate at which that pump is working? Well, it does 1/4 of the job per hour, right? So if T equals the time alone for the new pump, right? How long does it take the new pump to completely empty a single pool? Then the new pump's rate, right, is going to be 1/T. If the new pump could empty the pool in, say, 10 hours by itself, then every single hour it empties 1/10 of the pool. So its rate would be 1/10 per hour, 1/10 of the pool emptied per hour. The old pump does the same job, but it takes them 9 more hours. So T plus 9 is the time alone for the old pump, which means the rate at which the old pump works is 1/T plus 9. Okay, so now I can fill in the end of this chart that the old pump, the amount of work the old pump does, is going to be 6/T plus 9. The amount of work that the new pump does is 6/T. And together they're going to empty a pool. We can write that in down here in the equation. 6/T plus 9 plus 6/T equals 1 pool emptied. Okay? We can simplify this equation. We can make this equation a lot nicer by getting rid of all of our denominators down here, and we can cancel them out by multiplying by the LCD, which is T times T plus 9. Okay? Multiply by T times T plus 9 in every term, including the right-hand side of the equation you want to multiply by T times T plus 9, balance it out. Okay? This clears away our denominators. The denominators cancel out, and we're left with 6T plus 6 times T plus 9 is equal to T times T plus 9. Okay? The result here, after getting rid of those denominators, is a fairly easy quadratic equation. This is something that is factorable, that we can distribute. And on this side of the equation, after you get 6T, you'll be able to combine the two 6T's and get 12T plus 54 is equal to T squared plus 9T. Move the 12T over and the 54 over, subtract them over, and you're going to get T squared minus 3T minus 54 equals 0. This factors into T minus 9, T plus equals 0, T equals 9 or negative 6. Negative 6 is not a valid answer. Because time, we're looking for the positive value of time. So the new pump working by itself, because this is what we set up our variable T to be equal to, is 9 hours. It takes the new pump to complete the job. It takes the old pump 18 hours by itself to complete the job. Together they complete the job in 6 hours. Okay? Please make sure you include your units in the answer, and there we go. Okay?